It's very nice to be here. I'm Brad Hatfield. I'm a professor of kinesiology and neuroscience at the University of Maryland College Park. And with the dose-response conference, I'm talking about the dose-response relationship of physical activity, both to cell aging and to cognitive aging. Now, what's interesting is physical activity is generally conceived to be good medicine. And the Surgeon General's report back in 1996 and a current report from the Institute of Medicine documents the scientific evidence of the benefits of physical activity on a broad variety of different systems of the body. But the issue in terms of dose response is, could it be that you get too much physical activity? And I'm not talking about such things as bringing about arthritis and common sense notions that as we get older, the physical activity takes a toll, and therefore it would be just difficult to do more physical activity. But I'm talking more about subtle signs of distress on the body. So even in individuals who look like they're very high functioning and very physically fit, can we detect at a histological level that there is some kind of adverse effect on the body, when in fact most people think that there's nothing but good that comes out of the physical activity. So because physical activity can be considered a stressor when done at fairly high volume and intensity, we looked at the DNA in terms of structures called telomeres. And telomeres are the caps at the end of the chromosome which regulate the integrity and the stability and indicate the viability of the cell to keep on replicating. Once those caps or those telomeres become too shortened, then basically the cell becomes senescent and dies. So we looked at individuals who were between the ages of 50 and 70, men and women, all healthy, medically screened, high functioning, and we looked at various levels of physical activity and divided them into 4 groups. A low group, 2 middle groups, the third one progressively higher, and a 4th group, or the 4th highest quartile, which had the greatest volume and intensity of physical activity. In fact, the latter group would be considered to be masters athletes, people subjecting themselves to a fairly high level of training stress. And what we found surprised us, although it fits well with the notion of exercise being a chronic stressor, because we found that the people in the 2nd quartile who were doing walking, relatively regular, vigorous activity, but I'll call it moderate, they had the longest length of the telomeres, which would indicate an attenuation of aging or protective effect. And the individuals who were at the lowest levels of activity are relatively sedentary, and the individuals at the highest levels of physical activity had shorter, significantly shorter telomeres. And that would indicate that both the sedentary lifestyle and a highly vigorous lifestyle was actually accelerating the cell aging. So in this sense, a moderate degree of activity seemed to be promoting a healthful type effect at the cell level, and the vigorous activity was actually associated with a relatively negative histological event. Now, one of the ways we can interpret the findings here is that physical activity tends to be anxiety reducing or anxiolytic. And there is other companion research on the role of life stress with the shortening of the telomeres. And so one of the explanations could be this very strong anxiolytic effect of exercise is reducing the stress in the individuals and therefore attenuating this shortening effect on the telomere. So again, at a very subtle, relatively undetectable level in terms of behavior and general health, we find this inverted U type relationship between the dose of physical activity and the degree of cell aging. Thank you.